Ever wondered how a Formula One car can withstand G-forces that would crush almost anything else? It all starts with a material that can be thinner than paper, meticulously layered and baked into one of the strongest, lightest structures in all of motorsports. Today, we're going inside a cutting-edge factory where raw carbon fiber transforms into the very heart of an F1 machine, the monocoque chassis. Welcome to the pinnacle of composite engineering. What you're seeing here isn't just a factory. It's a high-tech laboratory where the laws of physics are pushed to their absolute limits. The journey from a simple roll of carbon fiber to the life-saving survival cell of a Formula One car is nothing short of incredible, and we're going to show you every step. It all begins with this, a roll of what's called pre-preg carbon fiber. Pre-preg simply means the carbon fiber fabric has been pre-impregnated with a specialized epoxy resin. This isn't just any carbon fiber. It's a specific grade, often developed in-house or in close collaboration with suppliers, tailored for the extreme demands of Formula One. Each roll is stored in massive, temperature-controlled freezers, typically at around -18 degrees Celsius. Why so cold? This prevents the resin from starting to cure prematurely. Once it's out of the freezer, the clock starts ticking. The material has a limited outlife at room temperature before it becomes unusable. Precision and speed are crucial from the very beginning. Before any material is laid, let's talk about the mold. This is the master form that will give the monocoque its final shape. These molds are themselves masterpieces of engineering, machined from special alloys or carbon composites to incredible tolerances, often down to fractions of a millimeter. They are polished to a mirror finish to ensure the final surface of the chassis is perfectly smooth for optimal aerodynamics. The design of this mold is the result of thousands of hours of computational fluid dynamics, or CFD, and structural analysis. Every curve, every contour has a purpose, either for aerodynamic performance or for structural integrity. Now, the real artistry begins in the clean room. This environment is meticulously controlled for temperature, humidity, and purity. Even a single stray hair or dust particle could create a weak point in the final laminate, which could have catastrophic consequences at 300 kilometers per hour. Here, highly skilled technicians, or laminators, take large sheets of the pre-preg carbon fiber, which have been precisely cut by a computer-controlled ply cutter. Think of it as a giant, incredibly accurate fabric cutter that follows a digital pattern. Each piece is labeled and has a specific location and orientation within the final structure. The technicians then carefully place each layer, or ply, of carbon fiber into the mold by hand. This is a painstaking process. They use special tools to smooth out any air bubbles and ensure perfect adhesion between layers. It's like a high-tech version of paper match, but with millions of dollars and a driver's safety on the line. The direction of the fibers in each ply is critically important. Some layers will have fibers running at 0 degrees, some at 90 degrees, and others at plus or minus 45 degrees. This multi-directional layup is what gives the monocoque its incredible strength-to-weight ratio. It can resist forces from every conceivable direction, twisting, bending, and direct impact. A typical F1 monocoque can have hundreds of individual plies of carbon fiber, sometimes with a lightweight aluminum or Nomex honeycomb core sandwiched between them for added rigidity and impact absorption without a major weight penalty. This core structure acts like the corrugated section in a cardboard box, dramatically increasing stiffness. As the layers build up, you can see the complexity. Different areas of the chassis require different thicknesses and ply orientations. The areas around the suspension mounting points, for instance, will be heavily reinforced to handle the immense loads generated during cornering and braking. The cockpit area, the survival cell, is engineered to withstand massive impacts and is subject to strict FIA crash tests. Technicians follow a detailed layup book, which is like a Bible for the chassis, specifying the exact placement, orientation, and type of every single piece of carbon fiber. There is absolutely no room for error. Once all the layers are in place, the entire assembly, still in its mold, is prepared for the curing process. This is where the magic really happens. The mold is covered with a series of breather cloths and a vacuum bag. The breather cloths allow air and excess resin to be drawn out, while the vacuum bag seals the entire thing. Powerful pumps then suck all the air out from under the bag, creating a vacuum. This compacts all the layers of carbon fiber together, squeezing out any trapped air and ensuring maximum density. This process is called debulking, and it's essential for a strong, void-free composite. With the vacuum applied, the entire package, mold, carbon fiber, and vacuum bag, is carefully wheeled into an autoclave. An autoclave is essentially a giant, high-tech pressure cooker. It's a sealed chamber that applies both immense pressure and high temperature. Inside, the temperature is gradually raised to around 180 degrees Celsius, while the pressure is increased to several times atmospheric pressure. This combination of heat and pressure activates the epoxy resin. The heat causes the resin to flow, filling any microscopic gaps, while the pressure ensures the final part is incredibly dense and consolidated. The resin then undergoes a chemical reaction, cross-linking and hardening, permanently bonding the carbon fibers together into a single, solid, monolithic piece. This curing cycle can take several hours and is monitored with extreme precision. After the curing cycle is complete and the autoclave has cooled down, the moment of truth arrives. The vacuum bag and breather materials are removed, and the newly formed monocoque is carefully demolded. What emerges is a single, black, incredibly light, and unbelievably strong structure. It weighs just a few tens of kilograms, yet it is strong enough to support the entire weight of the car and protect the driver from unimaginable forces. The surface finish is almost perfect, straight out of the mold, a testament to the quality of the mold and the layup process. But the work isn't done yet. The raw monocoque then goes to the trimming and finishing department. Here, robotic arms with high-speed cutting tools, or skilled technicians using precision grinders, trim away any excess material, known as flash. They'd precisely drill holes for suspension mounts, the engine, and various electronic components. Every hole, every cut is critical. A misplaced hole could compromise the structural integrity of the entire chassis. This stage requires the same level of precision as every step before it. Non-destructive testing methods, like ultrasonic scans, are used to inspect the chassis for any internal flaws, such as delaminations or voids, that might not be visible to the naked eye. It's a final quality control check to ensure the part is absolutely perfect. Finally, the monocoque is sent to the paint shop and then to the assembly bay, where it becomes the core of the Formula One car. The engine is bolted directly to it, the suspension is attached, the fuel cell is placed inside, and the driver's seat is custom fitted. This single component, which started as flexible sheets of fabric, is now the rigid backbone of a technological marvel, a survival cell that has saved countless lives in high-speed crashes. So the next time you watch a Formula One car thunder down the straight or carve through a corner, remember the journey of its heart, the monocoque. Remember the freezers, the clean rooms, the meticulous hands of the laminators, and the immense pressure of the autoclave. It's a symphony of material science, precision engineering, and human craftsmanship, all working together to create something that is simultaneously a work of art and a fortress of safety. It's the unseen hero of every single lap. Thanks for joining us on this incredible look inside the world of Formula One manufacturing. If you found this as fascinating as we did, make sure to hit that like button and subscribe for more deep dives into the technology that powers the world's fastest sport. Let us know in the comments what other F1 tech you'd like to see up close. See you in the next one.